Hello everyone, welcome to my channel. Today we will discuss on natural language processing NLP. Now what is natural language processing? Natural language processing NLP refers to the branch of computer science and more specifically the branch of artificial intelligence or AI concerned with giving computers the ability to understand text and spoken words in much the same way human beings can. NLP combines computational linguistics, rule based modeling of human language, with statistical, machine learning, and deep learning models. Together, these technologies enable computers to process human language in the form of text or voice data and to understand its full meaning, complete with the speaker or the writer's intent and sentiment. NLP drives computer programs that translate text from one language to another, respond to spoken commands, and summarize large volumes of text rapidly, even in real time. There's a good chance you have interacted with NLP in the form of voice operated GPS systems, digital assistants, speech to text detection software, customer service chatbots, and other consumer conveniences. But NLP also plays a growing role in enterprise solutions that help streamline business operations, increase employee productivity, and simplify mission critical business processes. Now, you might be thinking that what type of task does NLP does? Human language is filled with ambiguities that make it incredibly difficult to write software that accurately determines the intended meaning of text or voice data. Homonyms, homophones, sarcasm, idioms, metaphors, grammar, and usage expectations, variations in sentence structure, this just a few of the irregularities of human language that take humans years to learn, but that programmers must teach natural language driven applications to recognize and understand accurately from the start, if those applications are going to be useful. Several NLP tasks break down human text and voice data in ways that help the computer make sense of what it's ingesting. Some of these tasks include the following. Number 1, speech recognition, also called speech to text, which is the task of reliably converting voice data into text data. Number 2, part of speech tagging, also called grammatical tagging, is the process of determining the part of speech of a particular word or piece of text based on its use and context. Number 3, word sense disambiguation, which is the selection of the meaning of a word with multiple meanings through a process of semantic analysis that determine the word that makes the most sense in the given context. For example, word sense disambiguation helps distinguish the meaning of the verb make in make the great achieved versus make a bet place. Named entity recognition, or NEM, identifies words or phrases as useful entities. NEM identifies Kentucky as a location or Fred as a man's name. Then comes co-reference resolution, which is the task of identifying if and when two words refer to the same entity. The most common example is determining the person or object to which a certain pronoun refers. For example, she equals to Mary. But it can also involve identifying a metaphor or an idiom in the text. Then comes sentiment analysis, which attempts to extract subjective qualities, attitudes, emotions, sarcasm, confusion, suspicion from text. And the last, natural language generation, which is sometimes described as the opposite of speech recognition or speech to text, is the task of putting structured information into human language. NLP tools and approaches. Under this topic, there comes two things. Number 1, Python and Natural Language Toolkit, and number 2, Statistical NLP, Machine Learning and Deep Learning. Number 1, Python and the Natural Language Toolkit, NLTK. The Python programming language provides a wide range of tools and libraries for attacking specific NLP tasks. Many of these are found in the Natural Language Toolkit or NLTK, an open source collection of libraries, programs, and education resources for building NLP programs. The NLTK libraries for many of the NLP tasks listed above, plus libraries for subtasks such as sentence parsing, word segmentation, stemming, and lemmatization and tokenization. And it also includes libraries for implementing capabilities such as semantic reasoning, the ability to reach logical conclusions based on facts extracted from text. Number 2, statistical NLP, machine learning, and deep learning. The earliest NLP applications were hand coded, rules based systems that could perform certain NLP tasks but couldn't easily scale to accommodate a seemingly endless stream of exceptions or the increasing volumes of text and voice data. Enter statistical NLP, which combines computer algorithms with machine learning and deep learning models to automatically extract, classify, and label elements of text and voice data and then assign a statistical likelihood to each possible meaning of those elements. Today, deep learning models and learning techniques based on convolutional neural networks (CNNs) and recurrent neural networks (RNNs) enable NLP systems that learn as they work and extract ever more accurate meaning from huge volumes of raw, unstructured, and unlabeled text and voice data sets. NLP use cases. Natural language processing is the driving force behind machine intelligence in many modern real-world applications. Here are some examples. Number 1, spam detection. Number 2, machine translation. Number 3, virtual agents and chatbots. Number 4, social media sentiment analysis. And number 5, text summarization. So that's all for today. I hope you like it. Thank you.